Alright, this is example 1D3 from the book. So first, let's start off by reading what's given. Block B has a constant acceleration of AB equals 3 meters per second squared to the right at the instant shown. B has a velocity of 2 meters per second to the right. And we have to determine the velocity of block A and the acceleration of block A. At first, this may seem like they don't really give you a whole lot of information, but actually from the diagram we're able to figure out the position equation. And we're able to do this by separating the block right down the middle where it contacts the fixed point. And so we're able to see that block B has 3 lengths of rope attached to it, and block A has 4 lengths of rope attached to it. And all 7 of those lengths of rope add up to the total length of rope, which is a constant in this situation. So we get the equation 3 times the length of rope on the length of rope attached to B plus 4 times the length of rope attached to A equals the total length of rope, which is, again, a constant. And so from this equation, we're actually able to take the derivative with respect to time to derive both the velocity and the acceleration equations. So we get 3 times the velocity of B plus 4 times the velocity of A equals 0, and 3 times the acceleration of B plus 4 times the acceleration of A equals 0.
So from the previous equation derived by taking the derivative with respect to time, for velocity we got 3v plus 4va equals 0. And since in the problem statement it said to find the velocity of A, we solved that equation for VA to get VA equals negative 3/4 VB. And since VB was given in the problem statement, you simply plug in the velocity for VB and solve for VA to get VA equals negative 1.5 meters per second. The second part of this problem is to find the acceleration of block A. And since we have already derived the equation for acceleration, which is 3ab plus 4a equals 0, all we have to do is simply solve this equation for A, which we got the acceleration of A equals negative 3/4 AB. And since the acceleration of block A was given in the problem statement, all you have to do is plug in the 3 meters per second squared into the equation, and then you get the acceleration of A equals negative 2.25 meters per second squared.